All right, this is take like 20. We'll try this again. So we're talking about databases and an introduction to databases, sort of the history of databases. People first started organizing data for insertion and retrieval about 4,000 years ago when we were doing cuneiform tablets, and they were keeping track of grain or shipments or building materials or even people. But we're going to step forward and we're going to go all the way up to we're using paper. That'll get us at least far enough back to where I was alive. And so we had these papers and we would organize them, say, if we're doing a database for incoming freshmen to university. We'd gather all their information, their application, their transcripts, their recommendations, test scores, all that information, and we put it all together in a folder, and we would organize those folders based on their name, and then where would we store them? Right, we put them in a file cabinet, each by drawer, and we would alphabetize them by name. And so far, so good. Can the folders have different amounts of information in them? Of course they can. It's not a problem at all. Some folders can have just the transcripts or just the application, and it builds up over time. Life is good. And if you wanted to get a person, all you need to know is their last name. Person knows their last name. You go to the right folder. The file cabinet would have something like this on it, where it's, say, a 3-door file cabinet. It would have an index on the outside, G through M, and N through Z. And so you'd be able to find the right drawer, then scroll through and find the right person. And if it was in multiple rooms, in the hallway would be an index, and it would say, in this room are the file folders with people's last names, A to F, and then you'd go in, and then you'd find the right file cabinet with the last name, then the right drawer, and then you would search sequentially to find the correct folder. In big environments, that's what it would be. Now, this works really well. You can find the information, you can update the information. It worked really well. We ran the whole world this way. Now the problem is you can't go across folders. So say we have an incoming class of students, the marketing department says, how many students did we run an ad, how many students did we get from the 15222 zip code? And the answer is, I don't know. And the only way to find out is to sort through every folder, go through, find the zip code, and then on paper go 1. Go through the next one, next one, next one. Oh, find another one. 2. Not very efficient at all. So it works really well for one way of organizing information around one person. Now the next thing is we can only get to this data by last name. So the campus police want to find a ticket for a car, and all they have is a license plate number. Now the police can look up the license plate number because they have access to the state database, but if they didn't, what would they do? Well, there was no way they could get to the name of the person or to issue a ticket to them because all they had was the license plate number. So we need to get to this, people need to get to this same information based on different values, not just the name. So if we think of the name as the primary key, we need to access this in other ways. Now we solved this problem for books. Has anybody been to a library? You know, a library with like paper books where you actually look for a book? If anybody's done that, has anybody here used a paper card catalog? In a card catalog, there were 3 ways to get to a book. There was an index for author. So we had the author index. We had the subject index. And we had the title. And that was it. If you wanted to find a book in a different way, you had to search through every book by themselves. If you wanted to find all the blue books, you had to go look for all the books that are colored blue. If you wanted to find all the books that were 11 by 14, you had to go search through every one. The only way you could get to a book was if you knew the author, if you knew the subject, or you knew the title. And that was it. But every book had 3 entries in the card catalog. So if we were doing our folders, you could build alternate indexes as well. So for the marketing department, you might build an index for zip code. So you would be able to know every time you added a folder, you would update the index for zip code and write in the name of the person or the folder number for that zip code. This worked for a while, worked up when we started to then digitize all these forms. And at this point, when we started to put these on electronic format, this is where we lost our name and we all became numbers. Because we were working with large chunks of data where there were people with the same name, and no one liked that. So you no longer, you were a name, you were now a number. And we needed a unique ID number for everybody, and luckily we had one with the Social Security number, and then of course there were problems with that, so now we have to find some other unique ID for everybody when we store their information in the database. But now we had a number, and we were, even though we were doing this electronically, we still kept the same idea of the file information, and all we would do was store it on a magnetic tape, or if we had enough disk space, we would store it on the disk space, but disk space back then was real expensive, so it's mostly mag tapes for big databases. And what you would do is you would store the information in blocks, and then you would link the blocks for the file, so a single file might be spread out over multiple blocks on the tape. And if you wanted to add more information, you just add a new block and off you would go. So often you'd have to put everything back together again to make it all nice and neat to improve performance, but basically that's the way the world would work. Now, the next thing is we moved to, instead of storing it in blocks on tape, we started storing it in files. And at this point, it should start to look more familiar to you, because now we made files that looked suspiciously like Excel. So we had rows and we had columns. The rows were the elements for each item. So if it was an item database, it would be items going down. If it was a database of incoming students, it would be the students coming down. And the columns would be the variable information. So we have like ID, last name, first name, phone number, etc., all the way across. Now this worked out really well. Things worked out fine, but the problem was we started running out too much space. And if you only have one column for one person, you have to make that whole column and have all that empty space sitting there. So it was not very efficient at all. So we started to make multiple files for this, that would have different information in it. Now we're still not using the relational model. These are called linked lists or linked files, and at this point you might remember something on a PC, database 2, database 3, database 4, DB, which is not DB2 in the IBM world. This is not DB2, this is database. And in the relational model, which is what we're going to talk about a lot, we do the same thing, but instead of putting information in here just as we feel like it, we normalize the data. And that means we use special rules for what columns go in which tables and which columns can be even stored at all. And if we do that, and we do the joins in a specific way, we have a model that has ruled the database world for at least the past 30, even going on 40 years. Now we're starting to look at some NoSQL databases, some of the bigger databases that we're using now, like Amazon and Google, don't use a relational model, but still the relational model is the dominant model, and that's what we're going to spend most of our time on in this class. So that's our quick history of databases.